So in this lecture, we're going to add another derivative of another function to our repertoire here. So now we're going to start out with the natural log function. And so these natural log function is really the inverse of um, y equals e to the x. So I can think about this. So I can put this back like this is the log form of this. There's another form of it, the exponential form, which is basically e to the y equals x. So you can get there either by thinking of exponentiating, right, as these are powers, so then I get e to the y, e to the ln of x is just x. Or you can think of it as there's also, if I write this again over here, then there's also the sort of the putting it back into exponential form, which is e to this power. It's the base to this power equals this value, okay? So I'm going to use this because we already know how to find the derivative of e to the x, okay? So I'm going to do, now this is e to the y, so we're going to need implicit differentiation here, but we're going to take the derivative of e to the y equals x, okay? So when I do that, the derivative of e to the y is still e to the y, but then I took the derivative of y, so I tack on dy dx, and then the derivative of x on this side is just 1. So now if I solve for the derivative, which is just dy dx in this case, I'm going to divide by e to the y. Divide both sides by e to the y, and I get my derivative of e to the x is really 1 over e to the y, and up here we said that actually e to the y was x. Oops, so that means that this is really 1 over x. So we have a new rule now that the derivative of the natural log of x is equal to 1 over x. Okay, so then this also extends, like if I have the chain rule, like if I have the derivative of the natural log and I have some other function in here that I'll call g, right? Then this is equal to 1 over g of x times g prime of x. So we'll just put it on top. So really, when I'm doing the derivative of some log of a natural log function and I have something inside of it, really we just write the derivative on top as g prime over g. Okay? All right. So let's do some practice in here. Okay. So the first one, we have the derivative, and we're going to do the derivative of, obviously, chain rule. So this is like my giant g of x. So the derivative of this, f prime of x, is 1 over this whole thing. 1 over 2x to the fourth minus 6x plus 1. And then times the derivative, which I can just put on top with this 1. So the derivative of the bottom will be 8x cubed. Let me take away that 1, and then minus 6. And there is my derivative. So sorry, there was a 1 up there, and that's gone now. Okay. Now, because we're working with natural log functions, we can actually, now that one I couldn't really simplify anymore, but there's rules for my natural log functions that will allow me, in like a case like this particular one, to break it apart, right? So my log rules tell me that if I have things multiplied together, then I can write them then as the natural log of this plus the natural log of that. And if I have division, then I can write it as minus the natural log of this, right? And that works with all the bases, not just natural log. It's called the product property of logarithms or the quotient property. So we can write this, I'm just rewriting it, I'm not doing the derivative now, as the natural log of x cubed plus the natural log of the cosine of x minus the natural log of x squared plus 1. Okay. Now this is going to allow me to do my derivative in smaller bite-sized steps. So then I'm going to do, now I have plus in between them all, so I can just do individual derivatives. So then the derivative of the natural log, actually I could make this a little bit simpler still. For this one, actually I can pull down the exponent and write it in front. Okay, so now I've just got 3 times the natural log of x. So its derivative is just 3 over x, right? The derivative of natural log of x is 1 over x. The 3 was sitting out front, so it just gets multiplied. Then I have plus, I'm going to have cosine in the bottom, right, because it's 1 over this thing. The derivative of cosine then is negative sine, so I'm going to put that on top. And then I have minus, then I have 1 over this thing, so this will be in my denominator, x squared plus 1, and I put the derivative on top, which is 2x. And there is my derivative. So you do not have to combine them into a single denominator. Just leave it like this. It's perfectly fine. Okay, so we did natural log, but how do we do the natural, or what if it's not natural log? Okay, so then that requires an extra step. So if I just have y equals the log base b of x, right? So I could write this. This also means that b to the y equals x. So we'll do the derivative of this. So we know how to do the derivative of b to the y. I'm going to use implicit differentiation again. Okay, so I'm going to do the derivative of both sides. And on this side, I'm going to have b to the y, right? Because the exponential function always has, it's always itself. And then also times ln b, right? Because it's the natural log of the base. And then I took the derivative of y, so now I need to tack on dy dx. And then on this side, the derivative of x is just 1. Okay? So now to solve for dy dx, I just have all of this stuff. I'm going to divide by everything that's not dy dx, so I'm going to multiply or divide by b to the y ln b, and then I have b to the y ln b here. And then remembering that b to the y is really x, this is really just 1 over x ln b. So it's similar to the natural log of x, it's just that we have to tack on, we divide by the natural log of the base when it's not e. Really, we're kind of doing it when it is e, it's just that the natural log of e is 1. Okay, so that's an extension of that. So let's find the slope of the tangent line at x equals 1. Okay, so this time we have a log of base 2, so we're going to need an extra. So y prime equals, now the original is just the same, so I'm going to have 3x plus 1 down here, and then I'm also going to have the 3 on top from the derivative of this. So this is just like if it was ln, but then also down here I have to tack on the natural log of 2 because 2 is my base. Okay, so if I wanted y prime of 1, y prime of 1 is just going to give me, now there should be parentheses around there, 3 over the natural log of 2, and then when I plug in 1, I'm going to get 4 natural log of 2, okay? And that is just a number I can put in my calculator. Okay, so let's try another one. We have f of x equals the log of cosine of x. So initially I'm just going to treat it like it's ln, so I know that it's going to be a cosine in the bottom, right, and a negative sign on top because that's the derivative, and then times, now this is log with nothing said, so we're going to assume it's base 10, so this also has, oops, I wrote log instead of ln of 10. And there's my derivative. So I could technically call it, if I really wanted to, negative tangent of x over the natural log of 10, if I really wanted to. It's perfectly fine the way it is, though. All right, so that is doing the derivatives of log functions.